Namaskar, I'm Harpreet Kaur and I welcome you all to our live and interactive session on virtual labs. You are watching us right now on PM eVidya channels 6 to 12 and also on our YouTube handle NCERT Official. This session is specifically meant for the students of class 9 where we are taking the subject science, and today's topic of discussion is demonstration of simulation on VT graph for an object in uniform acceleration. Now, what is a VT graph and why it is important? What is uniform acceleration? So, there's so many terms in this topic today that we will try to understand through virtual labs. And how can we do that? Well, it's simple. You have to log on to a particular page and there you will find all the related content. But what exactly virtual labs are and why they are important, let me tell you brief about them. So, virtual lab is an online application tool that helps you perform simulations at your own time, pace, space and convenience. All you need is a stable internet connection and an IoT device. Also, it helps you understand the level of understanding you have acquired so far after going through the theory and the simulations. If you need more reference material, it also provides you the same. It is also very handy and useful for teachers, students and anybody who wants to learn different subjects through virtual labs alike, because we have content for everybody. Again, it is serving the purpose of inclusivity and equity in education because it is helping you access personalized content. Also, there are different medium of instructions. But what exactly the details of all these things are, you will figure out in a while. Before that, let me tell you, if you have questions, if you have any suggestions for us, please get in touch with us. Our phone number is 8800440559. We also have a dedicated email ID for you, that is diksha.training at CIET.nic.in. And on our YouTube handle NCERT Official as well, you can send us your questions, suggestions and your feedback. So it's a very interesting session. I request you all to kindly pay attention and also listen to our expert, and whatever she is displaying on screen, please watch it carefully. And now please join me in welcoming my guest for the session, Dr. Sharma, Ma'am is Consultant Academic from CIET NCERT New Delhi. Ma'am, namaskar and very warm welcome to the session.
Namaskar, namaskar ma'am.
So ma'am, it feels like a little tricky concept to me. First of all, it's a science for class 9 students, yes, and when you go towards 9th class and you study subjects, you're actually preparing yourself for the higher education in the chosen domain. If it's science, then you have to understand all the concepts very nicely. Yes. So first of all, please tell us, what is this VT graph? VT, I believe, is an acronym. What does it stand for? What is its usage? And the term uniform acceleration, what does that really mean? Also, why it is really important for us to learn about this concept? What is its importance in our lives?
Definitely, ma'am. Though it seems a very simple term, like it's a VT is velocity time, velocity time graph for an object moving in a uniform motion or uniform acceleration. But yet, when we draw the graph and analyze it, so it seems little bit complicated. So first of all, we will have to understand why this VT graph is more important, because it gives you a picture. It is very much crucial in the case of physics because it analyzes the motion of an object, whether it is moving in a uniform motion, whether it is moving in a non-uniform motion, it is having a constant acceleration, it having negative acceleration. So it gives all information about it, and the key information which this graph gives is about, the first thing is slope. It gives a slope, just seeing the graph we can easily analyze whether it is moving at a very high speed or whether it is moving in a very low speed or it is at a rest. So just seeing the graph, it is very easily understandable rather than the data itself. Suppose we have a data of velocity and time of a moving object. So by seeing this, we cannot predict the motion. So one of the important thing is it predicts the motion. And simply predicts like future like what kind will be the motion of that object which is moving, like especially in the projectile motion, like what kind of motion it will be there or what is the slope of that object will be after some time. So this gives that information. And second important thing which it gives, its area. So by seeing its area of the this velocity time graph, I just wanted to show you this picture also. Like if you see this picture, I have shown the simple diagram of a velocity time graph for an object which is moving in a uniform acceleration. Then see, this is a portion of uniform acceleration, this is at rest, and then it is speed is decreasing, its velocity is decreasing. So here the slope is negative, here slope is positive, and here slope is 0. So by seeing the graph itself, we just analyze what is the slope of this object, and slope is a gradient of this velocity and time, that is rate of change of velocity with respect to time, and this slope gives nothing but acceleration of this object. So this is a very key point over here. And second point is area under the curve. So by seeing this area, we can easily analyze, or we can easily depict that how much displacement it has covered.
Okay.
Since I am using the term of velocity, so it gives, the area gives displacement, because both are vector quantity. But if I made a speed and time graph, if I plotted a speed and time graph, in this case this area represents distance, because both are scalar quantity. And here we are saying that it is a vector quantity, so this area depicts its displacement. So how much distance it has covered: small area, small displacement; large area, large displacement. So these are the two key informations which can we can retrieve from these graphs.
All right. So that's very nicely explained, ma'am. Now I want to understand, you said that it is very important to understand any concept, and we can draw inferences easily when there is a graph.
Yes.
But can we understand the same concept through virtual labs? Because you have, you've drawn the diagram, you have made us understood the concept. But how can we understand that same through virtual lab? What lab is offering? What is this unique thing that we are getting from the lab, that it is easier for those who are not there in a conventional classroom to understand it by the teacher?
Sure, ma'am. I just wanted to show you how it is very much helpful in lab. So simply for that, what you have to do, you have to simply go to the Diksha platform here in this diksha.gov.in, and through the diksha.gov.in there are different focus areas are there, and one of the focus area, as we know, it is a virtual lab. So we will go to this virtual lab, and since it is a class grade 9th experiment is there, so I will go to the grade 9 experiment, and it is in English.
And ma'am, do we need to sign up for virtual labs?
Yes. One time sign up it requires. If you have a Gmail ID, you can log in through this Gmail also. Here it asks how to enter through this one window will open over here. As I already opened it, so right now it is not showing. So otherwise one simple window is there, login through Gmail. So you can log in through Gmail also. So that is a simple process.
And it's a free of cost tool, and we can access all its features.
Yes. So here this is a 33 number VT graph for an object in a uniform acceleration. So as you clicked it, you will get a different resource material. First is experiment PDF, then explanation resources is there. In experiment PDF, you will get a simple lab manual text input PDF, which is there, in which aim is there, theory is there, and what we are going to learn in this entire experiment, that is beautifully explained over here. So one by one we will go through it. So this is a theory part. So let's open this theory part first of all. The theory part is there. I hope it is visible. Yes. So the objective of this experiment is to plot the velocity time graph for an object moving with uniform accelerations from a given set of VT data, that is velocity time data, and to determine the acceleration of the moving object, what will the acceleration, and the distance moved by the object. So here itself all the applications are there. We can retrieve 3 information from here: what is the slope, what is the acceleration, and what is the distance moved by this object. So the theory is there. So the key terms which student must know before understanding this part is, first is speed, distance travelled upon time taken. They usually heard this in grade 6th, 7th and 8th also, but now we are integrating this theory part with this practical, like this graph part. okay, and if it travels a distance in equal interval of time, that is an example of uniform motion. So, by simply seeing that graph itself, if the line is straight, that means it is a uniform motion. If line is not straight, it is like a curvy type, so that is a non-uniform acceleration, because similarly acceleration is a change in velocity upon time taken. So, all this theory part is available here. The learner will go through this entire theory one by one. What do you mean by the velocity time graph? So, as I already mentioned, that it is simply a graphical representation of change in velocity of an object with respect to time, and its area gives the one dimensional quantity, that is a displacement, which is the SI unit is meter.
Right.
And here then slope of the VT graph, I have already explained what is the slope of this velocity time graph, this V2 minus V1 upon T2 upon T1. This is general formula, Y2 minus Y1, like if we plot it along x axis and y axis, this is general formula, m equals to Y2 minus Y1 upon x2 minus x1. Since we have taken along y axis velocity and along x axis time, so it is showing this thing. So, this acceleration is nothing but slope, which is m. So, it sharp steep slope, or like as I shown in the figure also, which kind of slope represents the by seeing this slope itself, we can identify whether it has a very high acceleration, low acceleration, or positive slope, negative slope, because if it is going below the time axis, in that case the acceleration is negative, because acceleration is also a vector quantity. So, vector quantity means which depicts its magnitude and direction also. So, if you are going in this particular direction, then you have changed the direction. So, obviously the sign, because we cannot show this direction otherwise, we have to show it like below the time axis. So, in this way the negative slope can be shown over here.
Okay.
So, this is the part over here.
So, this is the theory part.
This is the theory part, and in this simulation part, what we are doing, this kind of graph we can plot. There is a like simulation is there. The student just plot the different velocity respect to the time, and it is plotted. And normally in the practical lab, they use the graph paper and draw this straight line. And once after plotting these points, when we join this line, so if it is a straight line, that is it is a, because since we are learning only for uniform acceleration, so only one kind of graph we are getting here, that is of uniform acceleration only, because uniform acceleration, because it covers equal distance in equal interval of time, and here velocity is constant. Okay, so that is the thing. So, we will move to this second part. Then area, which I told you, which is a key information which we get during this experiment, that is this area of this VT graph, that how much displacement or how much distance it has covered during the entire journey. So, that can be easily derived using this formula. And if you see this this graph over here, the shaded portion, this blue portion, this is the area. We can simply calculate the slope. From the slope we will get the acceleration, and then if we calculate the area of this shaded part, this area gives the distance. This area gives the distance when the object move from point A to E. So, we can easily calculate this distance or displacement by calculating the area of this triangle ADE plus area of this rectangle. So, length into breadth, that is the area of rectangle, and this half base into height, that is the area of this triangle. So, when we have calculated it simply by this using this formula, simply by this formula, S equals to V1 T2 minus T1 plus half V2 minus V1 into T2 minus T1, we can, because all the information we got over here. So, putting all those values over here, we can easily calculate this distance. So, by simply one graph we can calculate so many things. So, it is indeed a very important topic of grade 9th, when the object moves in a uniform motion. So, which this kind, see now here I am showing you different example. When object is moving in a uniform motion, here you can see velocity is constant. V is not changing, because if you increase the velocity, what happens, the line will be not like a straight line.
It won't be a straight line.
It will be not, because since velocity is constant, acceleration is 0. Here slope is 0. As you can see from this picture, when the object is uniform acceleration, so this is the graph of the uniform acceleration, because we cannot this is the example of this velocity, this uniform acceleration. You can see the velocity is increasing with respect to time. Velocity is increasing with respect to time. So here it is an example of a uniform acceleration here. Now next, and when the object is in non-uniform acceleration, just theory part, because this thing I think we cannot plot it in a simulation. See here it is not in a straight line, it is there, random points are there. So sometimes velocity is increasing, sometimes again it is very increasing highly, then here it is decreasing. So it is not uniform. So it is an example of non-uniform motion.
Okay.
So importance, as I have already mentioned, this application, different applications are there. So one of this thing is we can analyze the motion. We can identify, first thing is we can identify the motion types, then we can calculate the key variables, which are slope and acceleration and distance or displacement we can say, and also we can visually analyze the entire motion of an object. Here these are mentioned over here, and we can also calculate using this graph. One can even determine the velocity or acceleration time beyond the range of time interval given in the data. That means we can extrapolate, we can predict the future motion. So this is called extrapolation of the graph, and this graphs gives this kind of freedom to analyze the motion. So these are the learning outcomes. Yeah. So I will quickly then.
Sure, ma'am. Now that we've understood the theory, I just want to ask one simple question. Is it in alignment with the NCERT textbooks?
Yes.
Okay.
Yes, ma'am.
So, ma'am, now that we've understood the theory portion, how can we perform the simulations, and do we get any help before performing the simulations apart from theory?
Yes, ma'am. Okay. I have already opened this thing. So this is the velocity time graph. Simulation portion is there. From that side only you will get. Now first option is show axis.
Okay.
And here the axes are plotted. Now then this is a help tab is there. Suppose you are not understood what we have to do. So it immediately tells you what to do next. Select axis. So time in x-axis and velocity, because since it is a VT graph, so V should be in a y-axis, or this T should be in a x-axis, or even if you want to change the reverse the axis, that can be also possible. Now already the observation table, this is given because since we are doing for the uniform acceleration, you can see that at the fixed interval of time you get a fixed velocity changes, like 10 differences there. So as I tick on this, I am getting the point plotted.
Okay.
So these points are, that means I have plotted these points. So one by one I am this plotting, then join points. So as you see, it is an example of uniform acceleration. So here the velocity is increasing because slope is positive. Now show coordinates. So by seeing simple, it shows the coordinate x, y, 5, 10. Now next feature will be enabled only when you give the answers.
Okay.
So it's not like it is interactive, like you are doing, no, it's not like that, whether you learned it or not. That is a very important thing in virtual lab, which I find very useful. Like identify the quantity defined as the ratio of a vertical change between 2 points on the graph to the horizontal change. What is that? That is a slope. I scored, then only it opens. Then change of velocity over the change, it is acceleration. If I give the wrong answer, it will not allow me to complete this experiment.
All right.
Okay. Now here one option is there, show scale. This is important. Whenever we plot a graph, we have to mention the scale. What is the scale you have used? In x-axis, I have used 1 centimeter as a 5 second, and y-axis as a 1 centimeter equals to 10 meter per second. So this scale is very much important. We have to mention in any kind of graphs. So this is
you said that you can't move ahead unless and until you give the correct answer. So if I give the wrong answer, will I get a hint to correct myself?
Let's check, ma'am. Let's check it. Like I don't know, I randomly click it. Now it's wrong.
Yeah.
So help. Click on the head. I think it is not giving that example. So I have to go back to the theory part, go back to the theory part, and then it allow me to complete the experiment. So that means theory should be important. Now since I have given the correct answer, now for that particular part I have calculated this acceleration, that is a slope 20 minus 10 upon 10 minus 5, which is 2 meter per second square. So this is a constant slope. Anywhere I go through the line, I get a uniform acceleration of 2 meter per second square. Now hide calculation, I can hide it. So for this part we have calculated it. Now show distance, that means how much distance it has covered while going from this point to this point. So show distance. So this formula which we have discussed in this theory part, the same formula we can calculate it, area of rectangle plus area of triangle. Then I have used this formula, and because I know the value of V1, what is a V1 over there? V1 is this V1, this V1 is 10, and this T2 V1, this is V2, then T2 is 10, T1 is 5, and V1 is 10, then half, what is V2? V2 is 10, V1 is V2 is 20, because we are considering this portion. No? V2 is 20, because we have used the scale. V2 is 20, this 20, V2 20 minus 10 into 10 minus 5. So from here I have taken this value and see how much distance it has covered. 75 meter. So from graph itself I have calculated how much distance it has covered. So I think this is like very beautifully explained over here. What will the distance covered, how much distance it has covered, and what is what is the acceleration is over there.
And you rightly said at the beginning that this simulation is very interactive in nature.
Yes, and we can see once it is done, we have shown the distance also, we can reset it. Now again you want to do this entire activity, we can reset it.
Suppose if I want to have negative slope, I can do the same as well here?
I think by simply plotting its, yes, we can do it definitely. Show this velocity in this time in x-axis. Let me plot in a different way. Next plotting. Now it is arranged in a because we are learning, the objective is uniform motion only. So negative slope it's not there. I have explained this in the starting also. Negative slope is not available here. Now next feature over
is evaluation, self evaluation.
Yes, it is there. Let me go over there. This is theory part is there, procedure we have done, then video is already available, this animation is also there. Now resources are there, learning resources. Now self evaluation, because we have done this simulation part, now we will move to self evaluation. So here in the self evaluation part, let me do the full screen. Yes, so verify the dependent variable in the velocity time graph. So this dependent is always a y-axis, because it depends on the x value, like at t1 how much velocity it has reached. So in this way we will do the evaluation. What is the term for the rate of change of velocity of an object? As I mentioned, it is an acceleration. So we can give the answer immediately. Then we will do the wrong answer also. Let it be the wrong. This is wrong. So immediately it gives the correct answer also, the blue color. So what does the slope of velocity time indicates? It is the acceleration of the object. It is correct. So because we have done this entire activity, we have plotted the graph, we understood the importance of graph, what is the slope of this, how slope is related to the acceleration, how the formula. So I think it is very convenient for the student to easily understand the concept, especially abstract concept of this physics.
Absolutely, ma'am. And I think once this learner has learned the theory, he has watched the animation before performing the simulation and perform the simulation as well, it's very easy to attempt the self-evaluation questions.
Exactly, ma'am. Exactly,
so, ma'am, we have very little time left. I just want to ask you one more thing, that if student wants to learn further, is there any reference material available for students?
Yes, ma'am. One reference material is there. That is a simply NCERT lab manual is there. But in lab manual, all the experiment, apart from experiment, various suggested activities are there, demonstrative activities are there, so they can go through it. Projects are there, they can go through it, and then referring to this topic, they will get a nearby topics also. So they can
for in
They go
previous
through them.
classes
Yes,
and
they can go through them.
the higher classes.
Yes, ma'am.
Also, I want to understand one more thing, ma'am. Like if students perform the simulation, they attempt the questions, and if they face any difficulty, can they give their feedback? They can write an email to us.
Yes, yes, they
Okay.
can write the email. They can write the email, definitely, ma'am.
All right. And ma'am, one last question. Like we have always understood virtual labs through the perspectives of students. How important it is for teachers to integrate virtual labs in their routine teaching and learning?
Definitely, ma'am. Like when they are teaching this concept to learner, so what they can do, they can divide their lesson plan in a such a way. Then, like just I have done that approach. I have explained the theory part in the classroom, and then after this theory, I have just integrated this practical part, like this plotting the graph part through this virtual lab thing. So we can integrate this graph to our concept, like the theory thing which we are going to teach. So similarly, teachers can do these things. They can integrate the similar topics to the students.
Right, ma'am. Ma'am, thank you so much for making us understand this topic so wonderfully. You not only explained it yourself, you gave us the theory, you gave us the tool which is virtual lab, and you helped us understood the concept through the same as well, and really like the way you draw things, you know, and it's very important to learn it different ways because we have different kind of learners who understand things differently. So thank you so much, ma'am, for your time and contribution.
Thank you so much, ma'am.
I'm sure the learners will practice the same and they won't forget it. In case you still find out any problem there, please contact us, and you have our email ID which is diksha.training@ciet.crt. And now let me tell you about the topic that we have learned today. It was simply demonstration of simulation on VT graph for an object in uniform acceleration. But tomorrow we will come up with another topic, and that topic will be for class 11 students. Subject will be mathematics, and we will be learning about demonstration of simulation on set theory using Venn diagrams. So again, we will see you tomorrow. Please make sure that if you have any query, you get in touch with us, you call us during the session, or you simply message us in our YouTube handle's chat box. But now this is not the end, because we have more programs lined up for you during the day. So let's see the program schedule, what's all coming ahead. So we're through with our session of virtual labs, and in a short while from now you can watch our another session which will be on inclusive classrooms, and it's going to be a session of English. We will be learning about vocation. Then we have back-to-back sessions from 2 to 5 p.m. At 2 p.m. we will bring you a session of Urdu followed by a session of English. We will be learning about Chandrayaan. 3 p.m. is the time for a mathematics session followed by a session of Hindi. 4 to 5 p.m. is the time for our online training program. This week we are talking about digital footprints, and we will end the day with our session Sahyog, where the topic is going to be effective communication and emotional expression for students. Well, with this, it's a wrap. This is me, Harpreet Kaur, signing off, and we'll join you shortly. Namaskar.